Hi, the purpose of this video is to explain some of the properties of a triangles, dealing with their angles and sides, and the angles of a quadrilateral. So I wanted to start off just by pointing out in a triangle, the three angles of a triangle must always add up to 180 degrees. Now this is a property that you need to know in order to understand how to solve for a missing triangle. Okay, so in this particular example, you have three angles in a triangle, which we know because of the property adds up to 180 degrees. So one way that we can solve this is by setting up an algebraic equation, adding these three angles together with one unknown and setting them equal to 180 degrees, like this one here. So we have 34 degrees plus 82 degrees plus n degrees equals 180 degrees. And now by putting the like terms together, 34 and 82, we can combine those two like terms to get 116 degrees. So this will give us now 118 degrees plus n equals 180 degrees. And to isolate the variable and solve for this equation, we would subtract 116 from both sides. Okay, and that would give us n equals 64, and that would be a 64-degree angle. Okay, so that's one way to do it algebraically. I know that we can just subtract from 180, and that would give us this angle, but in certain cases, we won't just have an n there. We'll have a more complicated algebraic expression, a variable expression. Okay, so this next example, we have one given degree measurement. Okay, now by knowing properties of triangles, we know that this little symbol here means that that's a right angle. And so this right triangle has 3-degree measurements of 32 degrees, 90 degrees, and this unknown n. Okay, but again, we have the property that says that all three angles add up to 180. So we can set up an algebraic equation with this one also. 32 plus 90 plus n equals 180. Combining our like terms again, 90 plus 32, that gives us 122 plus n equals 180. And then to isolate that n, subtract 122 from both sides, isolate the variable, giving us n equals 58. Okay, so that n would be a 58-degree angle. Now, in this case, we don't just have a variable representing the missing angle. We have a variable expression. 7x minus 3 is our missing degree measurement. Okay, so that means there's two steps. Once we solve for x in this equation, we then have to plug it in to find out how many degrees that angle actually is. So we would do the exact same method as we did in the previous ones. We would add up these three angles, 77 plus 50 plus that, equals 180 degrees. Okay, then combining our like terms, we now have a new like term. This -3 can be combined with the 77 and 50, and that would give us 124 plus 7x equals 180. And now we're just following the same steps of solving an equation. Subtract 124 from both sides, and that gives us 7x equals 56. Okay, and to solve for x, divide by the coefficient, divide by 7, x equals 8. Okay, now remember, that's not the end of it. That's only what x is equal to. We now have to plug in 8. 7 times 8 minus 3 would give us a 53-degree angle. Now, one property with the sides of a triangle is that the longest side of a triangle must be shorter than the two other shorter sides added together. Okay, so if you take that longest side of 30, the other two angles have to add up to be more than 30. And the reason is, if you picture the 20 and the 10, if you picture those with all the vertices lined up, you can't have any angle there, and the 10 and the 20 won't meet. Okay, giving it any tiny bit of an angle would disjoin them. So if you look at this triangle here, you have a 30-inch side, a side with 30 units, and then 22 and 12. So since those two are longer than 30, we can give them a little bit of an angle right here, a little bit of an angle right there, and they would still meet. Okay, so that's the property having to do with the side lengths, and we'll get back to this one. Have a few quiz questions. Now, with quadrilaterals, since you have a quadrilateral, which is pretty much, if you divide it diagonally, you'll have two triangles. So the four angles add up to 360 degrees. So if we were to set up an algebraic equation the same way we did with the triangles, we would add up all four of these and set them equal to 360. So we got 90 plus 90 plus 119 plus 2x plus 3 equals 360. Combining our like terms, 90, 90, 119, and 3, we get 302 plus 2x equals 360. The 2x we bring it down. To isolate that x term, we have to get rid of the 302, so we subtract 302 from both sides, giving us 2x equals 58. And then dividing by our coefficient, always the final step, x equals 29. Okay, now again, this is not a 29-degree angle. We plug it in to the x. So 2 times 29 plus 3. Okay, so that gives us a 61-degree angle. Okay, so a little test here to see if you understood this. So go ahead and pause it if you want to solve this one. Okay, you got four angles, and just remember that a quadrilateral adds up to 360. So we'll set it up. 95 plus 59 plus 121 plus b equals 360. Our three like terms right here gives us 275 plus b equals 360. Subtract 275 from both sides to isolate that b. Okay, that zeroes out, giving us b equals 85. Now, since that's b, that gives us our degree measurement. So that's an 85-degree angle. All right, so now just a little test on the sides of a triangle, see if you understood that. So let's say we have three sides of a triangle that are 4, 12, and 24. Will those meet? Can you have a triangle with those sides? Okay, so picture 24 being the longest side. If the other sides are 4 and 12, can they meet? The answer is no, they can't, because the two shorter sides add up to 16, which would never meet when joined with the vertices on 24. Okay, for B, will those make a triangle? The answer is no, they won't, because the two shorter sides add up to 18, and they are not longer than the third longest side, 20. And then the third, if you have 5, 8, 12, can you make a triangle? The answer is obviously yes, because 5 and 8 add up to 13, and that is 1 unit longer than the longest side. So you can give it a little bit of an angle, and they will meet. So hopefully this helps your understanding a little bit about triangles and quadrilaterals and their angles.